Common mistakes in custom MATLAB code for XOR neural network. When developing a custom XOR neural network using MATLAB, it is crucial to be aware of potential mistakes that can lead to incorrect outputs. These errors can affect model accuracy and undesirably increase the time spent debugging. Below are some common pitfalls to watch out for when working with your neural network code in MATLAB. Data preprocessing issues. One frequent mistake is the improper preprocessing of input data. For example, failing to normalize or scale inputs appropriately can lead to ineffective learning. XOR neural networks typically handle inputs that are binary, however, when expanded to wider applications, ensuring that input data is within an acceptable range is necessary to attain accurate results. Network architecture misconfiguration. An error in configuring the neural network architecture can result in poor performance. The XOR problem famously requires a hidden layer to solve it, as it is a non-linearly separable problem. If you attempt to solve XOR without adding a hidden layer, your code will not converge correctly. Always ensure an adequately complex network architecture is set up for the complexity of the task. Inadequate initialization of weights and biases. Initializing weights and biases too high or too low can severely affect learning. Random initialization is oftentimes used, but you must ensure that the chosen range of values encourages the neural network to converge during training. Proper initialization helps avoid issues with activation functions saturating or vanishing gradients. Learning rate and training algorithm misalignment. The learning rate specifies the step size during optimization of the neural network. Using a learning rate that is too high or too low may cause the model to overshoot optimal solutions or converge too slowly. Choosing an appropriate learning rate is a delicate balance and might require adjusting based on the results. Ensure that the optimization algorithm you're using aligns with the chosen learning rate. Misdefinition of loss function. Another common mistake is not choosing the right loss function for your model. For a binary classification problem like XOR, using a loss function such as binary cross-entropy is typical. Using an improper loss function may not penalize the network correctly for errors, leading to suboptimal model performance. Forgetting to check for overfitting. After your network appears to have learned the XOR logic, it's crucial to validate it with additional data. Watch for overfitting by potentially dividing your data into training, validation, and test sets and examining how well your model performs on these unseen samples. Debugging and validation techniques. Modifying the network and then rechecking against known inputs and expected outputs can help validate that issues have been resolved. Utilize MATLAB's debugging features, such as breakpoints and the workspace, to step through the code and inspect variable values during runtime. By being aware of these common pitfalls and addressing each as needed, you can improve the accuracy and robustness of your XOR neural network implementation in MATLAB. Continuous testing and iteration are key, especially when you tailor to a specific problem requirement.